Hello there guys, welcome back to another epic inexorable maths video. Once again, we're looking at integration by parts. There's the formula for integration by parts, and as promised guys, I'm just going to move out of the way of the screen a little bit for a second. Here's the product rule. What we're going to do is derive the formula for integration by parts. I said in the last video, link is in the description, I said in the last video when we first looked at integration by parts that this formula here in yellow, this comes from the product rule for differentiation. It's really, really easy to derive actually if you know what the product rule is. So I've written the product rule down. This is the product rule for differentiation. I very much hope that you are happy with this formula by now. So it's the product rule for differentiation. Once again, what it says is that the derivative of the product of two functions, so u and v are both functions of x, the derivative of this product is equal to u times the derivative of v plus v times the derivative of u. Again, just the product rule from differentiation. So the way that we're going to essentially get the formula for integration by parts, believe it or not, we're doing integration. We're just going to integrate both sides of the product rule formula. So guys, I'm just literally going to integrate both sides. So integrate this side with respect to x is equal to the integral of this side with respect to x, okay? That's the first step. We literally just integrated both sides, nothing too crazy. Then what we're going to do is simplify it slightly. So first of all, what is the integral of the derivative of u times v? Well, you already know that integration and differentiation are inverse operations, which means that the integral of the derivative of something is just the thing unchanged. So this left-hand side is just u times v. Okay, then the right-hand side, what we will do is we will use what's called the linearity of integration, which sounds complicated, but all it is it just means that the integral of the sum of two things is the sum of the integrals. So I'm going to write this right-hand side as two integrals. The first integral is just u times dv dx, and the second integral is just v times du dx. So all I'm doing is I've got the integral of two functions adding together, and I'm going to write that as the sum of the separate integrals. So I've not done any integration by parts or anything. I've literally just said it's this integral plus this one. I've written them separately. Okay. And the reason that I've done that is because now you can see it already. Look at how close what we have here is to this. It's so close. We're so close already. And then all we're going to do is we're going to choose either this one or this one to make the subject of the equation, and we're going to get that on its own. So I think we should get the integral of u times dv dx with respect to x on its own, just because it matches that formula. What I will say is it technically doesn't matter which way round you have this. You could start off with this being on its own, and it could be equal to uv minus this, but let's not go into that too much. It's literally, it's about letters of the alphabet, guys. It doesn't matter what the symbols are. So anyway, I'm going to get the integral of u times dv dx on its own, okay? So the integral of u times dv dx with respect to x. So I'm going to kind of leave this here, and I'm going to move this integral to the other side, but then I'm going to kind of swap them around. So I'll write it down, and you guys can have a think about whether you're happy with what I've written. Okay. All right, so stare at that. Have I rearranged the equation correctly? I believe I have. And look at that, guys. It matches this formula here. That's literally all you have to do to get the formula for integration by parts. Okay, so also what I'm going to do in this video is give you what's called the order of priority for what you should let u be equal to when you do integration by parts. Because also, in the last video, what I said is that it does indeed matter which way round you label u and dv dx. It does matter. It's important. It actually is the make or break between you getting the question right and wrong. When you do the product rule, it doesn't matter what u is and what v is. You can swap them around. But when you do integration by parts, it does matter what you label u and what you label dv dx. It does matter. So there is a nice little kind of what would you call it, an acronym for determining the order of priority of what you should let u be equal to. So I'm going to I'm going to write it down, and I'll see you in a second. Okay guys, so here it is. This is an acronym, I guess, LIATE, L-A-T-E, LIATE. There is a little, there's a space here. I'm going to talk about what the space means in a second. But for now, this is kind of how to interpret what I've written. The higher up the list is, the more priority that type of function should have when you're labeling between u and dv/dx. So the higher it is, the more you want it to be u. The lower it is, the more you want it to be dv/dx. So whichever type of function is higher, that should be u. This is a general rule of thumb. I suppose there can be exceptions, but as a general rule of thumb, 99% of the time, this is how you should do this. So I'll give you an example question in a second, but I just want to talk about why I've left a space here. Because for most people, this is all you need. It's just LIATE, logarithms, algebraic, trigonometric, exponential. But there is, I guess, a fifth function that can sometimes come up that I think is worth writing, but I'll write it in yellow. And it's an I, so it's like LIATE. And this is inverse trig functions, okay? So you can either include this when you remember it, or you don't have to, depends on how important you think that is for you, for what you're learning, but inverse trig. So let me just, first of all, let me just talk about what exact functions do I mean with all of these. So logarithms, I am talking pretty much 99% of the time, the natural log of x, okay? The natural log of x, natural log. But it could be any logarithm technically. Log base 10. It's quite rare that you would need to integrate log base 10, I guess, but it's possible. But this is going to be the natural log most of the time. Any logarithmic function, the natural log of x, the natural log of something else, the natural log, whatever you want, the natural log of 1 plus x squared or whatever. Inverse trig, this is just literally the inverse trigonometric functions, things involving arctan, arcsine, arccos, blah, blah, blah. Algebraic functions, these are powers of x, polynomial functions. So things like x squared, the square root of x, 1 over x, basically x to a power, okay? Trigonometric functions, these are also self-explanatory. Sine, cos, tan. You can also have the weirder ones, cosec, sec, cot, all of those. And finally, exponential functions, things like e to the x, e to the 2x, e to the minus x, 2 to the power of x, anything where x is in the exponent. That's an exponential function. So again, the higher up the list is, the more you want that type of function to be u when it comes to labeling when you do integration by parts. So for example, let's say that we were doing the integral of x times the natural log of x. Have a think about it, maybe pause the video for a second, and I'm going to get out of the way so you can pause and have a look. What should be u and what should be dv/dx? So one of these functions between x and ln x, one of them needs to be u, one of them needs to be dv/dx. Which way around is it? Pause, have a think. Okay, now I'm going to tell you, you should let u be the natural log of x, and you should let dv/dx be x. That's the way around that you should do this. Why? Well, because the natural log of x is a logarithmic function, and x is an algebraic function. Logarithms are higher up the order of priority, they're further up, so that means that they have priority when it comes to labeling u. So u is the natural log of x, and dv/dx, because it's lower down, because it's an algebraic function, it's an algebraic function, because of that, that's what's going to get labeled dv/dx. If you want to see me actually do this, watch the next video, because this question is going to come up in the next video and we're going to fully go through it. But for now, I just wanted to see it's about the order of priority. That's what this video is. If you want to actually see the integral, stay tuned for the next video. Thank you guys so much for watching. I highly appreciate it. And I'll see you in the next video.